Hey, hello everyone. Welcome back to another episode of Strings Lead Code Questions. I'm following the tech interview handbook guide, study guide. So this is we are at the top in topic 2, question 1 of essential questions of strings. So let's take a look. Given two strings s and t, return true if t is an anagram of s and false otherwise. An anagram is a word or phrase formed by rearranging the letters of a different word or a phrase, typically using all the original letters exactly once. Okay, so it basically means that you take all of these characters, you can use them once and you can rearrange them the way you like it, and T should be one of the resulting rearranged characters of S. And if it is, you return true, otherwise, you return false. Let's jump into the Scratchpad to see how we can really do this. Now let's look at some ways to solve this question. So the first approach that I'd like to show you is sorting approach. So what happens if we just sort the two strings and check if they're the same thing? That would work, right? Let's see. Let's sort S. So S becomes, let's see, A, another A, then M, no, then G, sorry, then M, then N, and then R. Okay, that's S sorted. What about T sorted? Let's see, let's get the A's first. So one, two, three, A, G, M, then N, then R. If sorted ascendingly, these two should equate, and that should return the correct answer if we just do S double equals to T. Now, now the space complexity for this, now the time complexity for this is obviously like whenever you're sorting using inbuilt function, or like the most efficient version of sorting is O n log n, and while while this is n on like n on n log n time complexity solution, it is definitely a O of one space, because this depends on the sorting implementation we use, but it usually costs O of one auxiliary space if heap sort is used. Um, okay, that's the answer. That's the first approach, that's sorting. Okay, let's look at the next approach. So we looked at sorting. Now let's look at a frequency counter solution. So frequency counter. So like the name suggests, we would parse through every array and create a frequency dictionary out of these two, and then try to see if they have the same amount of characters. Now, let's assume we have a dictionary called S frequency, which has no elements inside. So we'd parse through, let's see A. A is not there in our dictionary. So we'd initialize A to 1. N is not there in our dictionary, so we'd initialize to 1. A, it is there, so we would update this value. G, it's not there, so let's initialize. R, It's not there, so initialize another A. So this now becomes 3 and M. M is 1. Let's assume we have another dictionary that says T frequency, and now we would populate these values. So N here maps to 1 since there are no elements. We have A again on this part of the dictionary. That's 1. G, you'd say 1. A again. So this would become 2. R, 1. A again. So this would become 3. M, new element, 1. Now, if S and T are really anagrams, they would have the same amount of the same numbers mapped to each of their characters, and everything in T frequency, all the keys at least, should be there in here. And if it's not, we just immediately return false. So we return false in two ways. So the first way, if the value is not found, value of S freak is not found, or value is found but it's not equal to T freak value. Okay, and now let's talk about the time and space complexity. So the space complexity would be O of 1 because there are only 27 characters in like Latin text. So it would not be O of n because it's not ever growing. It's a set number of characters in a dictionary. We're just updating these values. So it's O of 1. And time is actually O of n to go through each one of these once and once only, and not in a nested manner. So yeah, these two are the time and space complexities. Now let's look at the code for these two solutions. Okay, let's really quickly look at the sort solution. So it's pretty simple, it's just straight line. But before we return anything, let's just check if s.count is actually equal to t.count. Otherwise, there's really no point of checking, right? So guard s.count is equal to t.count, else return false. Now once we have this, we can just return now. First we convert s into an array and then sort it, and then compare those two arrays with the same exact result for t, and this should do it. Now we're sorting it twice, so it should be 2n log n, but since we don't do it that way, we just take n log n and ignore the constants. That's the time complexity. Let's run this. Let's submit it. I'm sure it would get accepted, but it's not really the ideal way of doing this. Okay, let's reset it and see how we can do it the second approach that we just saw. Okay, we spoke about creating two dictionaries, right? So let's initialize them as frequency from a character to an int. Now remember, in Swift, when you try to parse through a string, it doesn't give you a string, it gives you a character. So if you say, if you try to do any of these string operations on that specific character, it won't run. So and these two would be O of 1. Why? Because just think about it. We are parsing through only English characters here, lowercase English characters. And English characters are limited, right? So 27. So we already know the size of this dictionary. It's just a matter of what's the int going to be that's mapped to the characters. So this is O of 1 space. Now we have to build these dictionaries, right? So we would just parse through the strings for s string and s, and we would check if there is a value of s string in the existing dictionary. If it's not, we would initialize one. So if let underscore equals to s frequency of s string, and otherwise else, if it exists inside, we would just update it, right? So s frequency or s string plus equals to s string plus equals to 1, sorry. And this would be optional, since this is a way to do it, but this would give us the value and I don't really want that. And since we're not even checking for um, really like typing it out for this optional value, we can force unwrap it because we know it will always be there. um, now if this block of code fails, you would just say s freak of s string equals to 1. Now let's copy this down once and change up stuff. T string in ts, just replace every s with t, and we'd be building the t string similarly. Now when it comes to equating them, how would we do that? Let's think about it. So we can get all the keys, right? So let's get all the keys for s frequency. So for key in s freak dot keys, and if you wanted values, you could just do values. We would start a guard statement for if a value would exist in t frequency for this key in s frequency. Otherwise it would return false. And then we would check if this value is actually equal to s frequency key's value at that point. So if value double equals to, you know what, let's call this much more specific. So t frequency value, if t frequency value double equals to it's not equal to s frequency of key. Now we want to return false when it's not equal to this value. If this value is not equal to this value, we return false. Now that we covered all the cases of returning false, we just return true if this block of code passes, and that's it. So this would take O of n, sorry, this would take O of n space, no, time. This would take the same thing, and let's assume this would take the same thing too. So in the end, we would have time is 3 O of n equals to O of n, and space is, like we discussed, O of 1. And that's it. We run the code. Oh, what's the oh, this is t frequency. I copied it, but it didn't change the character. Okay, now that runs. Let's see this. Oh, what's the issue? Let's see. You can use a card statement here, maybe s dot count is equal to t dot count, else return false. Let's give it a spin. Okay, that was the issue. Okay, that works. Awesome. If you like these kind of videos, do let me know by liking and consider subscribing. It would help me, kind of motivate me to make these videos. And I'll see you guys in the next video. Thanks for watching.